So, good day, everyone. Good morning. So, today we will explore the world of chip manufacturing and some related topics that shows how complex and important chip making is to the modern or the technology now. So, let's start with the basic and what exactly is the chip. So, in simple terms, a chip or integrated circuit is a small piece of silicon that contains sometimes even billions of tiny electrical components. These chips are like the brain of electronic devices, processing information and making the functioning of everything from your computers that you're using right now, from the smartphone to cars to the most advanced supercomputers. So, making chip, however, is not an easy task. Since the process starts with the raw silicon, which is refined into wafers and then cut into tiny little pieces that will become individual chips. Then each of these chips is built up in layers where intricate circuits, what do you call this? Where intricate circuits are created through a series of complex steps. This process is called lithography. So it involves projecting patterns onto the silicon to refine where tiny components like resistors and wires will go. It's a high-step process, and any mistakes like misaligned layer can ruin a batch of chip making. So chip making requires an extraordinary precision, and that's why only a handful companies in this world or worldwide have expertise to do it. So chip and CPU making is so hard to make. So for our next topic, now you may wonder why chip making is so challenging, like what I said earlier. So one reason is extreme level of miniaturization involved. So making miniature chip is very hard. Imagine trying to fit billions of transistors onto something smaller than your fingernail. Each transistor is so tiny that measured in you can measure it in nanometers, I think. That even dust particles can cause huge problem in manufacturing. So companies uh, have solutions to avoid contamination. So factories also known as fab, use highly controlled environment called clean room where they can where even a stray hair rather could disrupt the process of those. Moreover, each chip has multiple layers, sometimes more than 100, each carefully aligned to one another. The manufacturing process has to be performed under exact conditions, for instance, temperature, humidity, and even slight vibration can impact chip quality. So fab, the factory, the manufacturers spend billions of dollars on equipment and facility to maintain these conditions. These critical aspects. And because the demand for smaller factory chips increase, companies are constantly pushing the limit of current technology to make transistors even smaller and more efficient. And also, less efficient, more efficient to us. And, everything now is getting smaller. So another thing is we're going to talk about is the photolithography. So this is one of the most critical steps in chip making. This is called photolithography, which is how those intricate patterns are created on silicon wafers. So photolithography involves using ultraviolet light to film very detailed patterns on the wafer, defining where each transistor and wire will go in the chip. It's similar to how an image is projected onto a screen, except this screen is smaller than a grain of rice, and the details need to be incredibly fine. For this step, machine called photolithography scanner use lenses and mirrors to shrink the pattern to a fraction of its original size, down to nanometer precision. The challenge is that as chip gets smaller, they need even finer patterns, which requires an extremely short wavelength of light, specifically UV light, to achieve the detail. That's why companies are now using advanced photolithography techniques like extreme ultraviolet lithography, I think, what they call EUV, to produce these tiny features. UV light is so powerful and precise that it has revolutionized how chips are made, but the machines to generate it are incredibly expensive and complicated, making them a huge investment. So for the next topic, we're going to tackle how CPUs are made. So for CPU, this CPU is the what we call heart of most devices, at the heart of most devices or the brain. So we have CPU or the central processing unit, which is a very not a very small, but a small part of a computer. So this chip is a part that executes instructions and process data, making a CPU is similar to other chips, but has some unique challenges due to its complexity. It started the design phase, where engineers create the architecture, deciding how the CPU will handle instructions, manage power, and ensure data is processed efficiently. Once the design is finalized, the manufacturing process begins. So first silicon wafers are prepared and coated with photoresist material. So then photolithography is used to imprint patterns on the wafer over several stages. Layers of transistors and connections are built up. These transistors act as switches, allowing the CPU to control the flow of electricity and perform calculation. After all the layers are completed, the wafer is cut onto or sorry, into individual dies, each one of a separate CPU. Then come testing. Every single chip must pass in a quality control check. Some CPU will perform better than the other due to minor variations in the manufacturing process. These are marked at higher performance and are sold at a premium. So, as you can see, all the CPU in the market have different variation in speed. So mm, that's why they are priced as much as the other set of CPU variation. While also, if there's a premium, there's maybe slight slower and are used in a budget devices. That's why they sell it in more cheaper price. So in the end, the final products are then packaged and labeled and sent off to use in everything from high-end servers to basic household gadgets. So that's how CPU is made. And for the next topic, or the last one, is the future trends of the computer engineering profession, the top 10 technology to learn in 2024. So chip making continues to evolve, but it's also directly tied to the larger trend of or in computer engineering. Looking to the future, there are several technologies and fields that are expected to shape the industry. For example, the AI, artificial intelligence, is one of the biggest trends right now. So AI algorithms are now used to optimize design and predict potential issues. Also, in chips, before they even manufactured. This saves time and money to companies, but also help produce more reliable and powerful chips. Another emerging area is the quantum computing, so which could revolutionize computing by enabling operation at speeds we can barely imagine with classical computers. Quantum chips, however, are vastly different from traditional ones and required their own unique manufacturing process, pushing research in new directions. There's also trend towards 3D stacking of chips instead of laying all the components side by side. Engineers are developing ways to stack them vertically. This is not only takes space, but also allows for faster data transfer between layers, making more device more efficient. And also one thing is machine learning. Machine learning is being applied within manufacturing lines to predict faults and improve quality control. Additionally, computer engineers are exploring energy efficient chip design specifically for Internet of Things or IoT devices where low power consumption is critical. With such advancement, it's clear that chip making is not just manufacturing process, but a major field of innovation in the future. Engineers in the field must stay updated on these trends and continue to learn new skills. Technologies like blockchain, 5G, and cloud computing are also influencing how we design and use chips. So if you're thinking pursuing a career in computer engineering, these are the areas worth exploring as they will likely be major part of the industry in the coming years or in the coming future. So to wrap up with chip manufacturing, chip manufacturing is one of the most complex and essential process in modern technology. The world continues to rely more on advanced technology, the role of computer engineers and chip manufacturer will only grow. Understanding chips manufacturing doesn't give us insight onto how our devices work, but also help us appreciate the immense effort and the immense in ingenuity that goes into every device we use. It's the build up at the cutting edge of both science and engineering, constantly pushing the boundaries of what's possible. So, thank you for joining me on this journey onto the road of chip making and computer engineering. I hope I give you a best reflection, and I hope this has given you a deeper understanding of process and the future of exciting field of computer engineering. So, thank you for listening and hope you're doing fine and bye bye.